So this is a supplementary Algebra 2 lesson for textbook lesson number 63 in your books, addition of vectors. I'm actually going to go over one of your homework problems, lesson 63, number 7. So you might want to write this down, or you can play it again several times to get the work down, okay? But first, what are we doing when we are adding vectors? Remember, a vector is something that has a distance, a magnitude they call it, and a direction, okay? And one thing we have to realize when adding vectors, it's not like adding numbers. We can just add 2 plus 2 and get 4, okay? It depends on the direction of the vector. We can only add vectors directly, 2 plus 2, if they're in the exact same direction. In other words, if I go walk, okay, 4 miles to the east and then 3 miles to the north, okay, what is the an expression of the where I end up? In other words, from the origin, okay, it would be 5 miles at an angle of 36.9 degrees, okay? And we notice if we added 4 plus 3, that would be 7. That does not equal 5, okay? That when we add those two vectors together, okay? Because they're not in the same direction, okay? So what we have to do is we break apart vectors and add the components that are in the same direction, okay? We add the x component and we add the y component, okay? Now, we do that in this case, we add the two components, okay? It's plus 4 in the right-left direction. It's plus 3 in the up-down direction, okay? That is an expression in polar form of this final vector when we added them, okay? So if we square both of these sides with Pythagorean theorem and then take the square root, we will get 5, okay? We determine the angle of the vector addition by taking the inverse tangent, opposite leg over adjacent leg, okay? That gives us the angle 36.9, okay? And that is the expression of that vector in polar notation, okay? Here's an expression of that vector in rectangular notation, or rectangular coordinates, okay? Now, in the case of two vectors that aren't perfectly left and right, up and down, okay? Problem 7 says to add a vector of 30 units at an angle of 45 degrees to a vector of 10 units at 160 degrees. And here I have those drawn, okay? Our first vector in orange, 30 units at an angle of 45 degrees from the x-axis. And then I am adding to it, and by the way, for doing vectors graphically, and you'll have to do this in future science classes more than likely, to add vectors, we start with the tail of the first vector and go how long it is and at what angle. We put an arrowhead. Then we put the tail of the next vector and how many units at what angle and an arrowhead. And we just keep adding arrows and arrows to each other. Okay, that's what I've done here. So the next vector is 10 units at an angle of 160 degrees. Okay, so if we had that vector down here, 160 degrees would be off in this direction. We keep that same angle up here. So we would get a final vector, this bold red one here, okay, if we were to add them together. We can express those two vectors as one vector added together. Well, first of all, what do we have to do? We divide the orange vector, the first vector, into its triangle, into a right vector and an up and down vector, okay? And we divide the second vector, okay, this yellow one, similarly, into a right vector and an up and down vector, okay? So you draw your reference triangles and then split them up. Now, I told you that we have a short shortcut way of doing that. Okay, for r, it's simple. It's simply the hypotenuse, that 30 length, times the cosine of the angle, 45 degrees. Okay, that will equal 21.2 in this case. Okay, I'm going to go ahead and shift my screen down so we can fit all the work in. Okay, and then for the up-down component, the shortcut is the hypotenuse length, the 30, times the sine of our angle, 45 degrees. Okay, that comes up to 21.2 as well. Okay, I express that in polar form. Now is when I put in the plus or minus sides. What am I doing? I'm actually going to the right in positive direction. So it's a positive 21.2r, and I'm going upwards, a positive 21.2u. Okay? I do the same drill with the yellow triangle. Okay? My r is equal to the hypotenuse length, 10, times the cosine of the angle, which is now 20 degrees. Why 20? Because I'm taking the angle that's back down to the x-axis. If that vector were measured from the origin, 160 degrees would be out here. This is the 20-degree angle I would use back to the x-axis. Okay, and that's that same angle here, the 20-degree angle. Okay, r then becomes 9.4. Similarly, u, the shortcut method, is the hypotenuse length times the cosine, or the sine of the angle, 20 degrees. Okay, that equals 3.4. Okay, in rectangular form, now I assign the negative or the positive quality to that direction. I am going to the left in the r direction, so it becomes a minus 9.4 r. I am going up in the up-down direction. That's a positive 3.4 u. Okay, so what do? I simply add, and the book just stacks these one on top of the other, but I can just simply add 21.2r, okay, minus 9.4r. That equals a positive 11.8r. Okay, I take a 21.2 positive u and add to it a 3.4 positive u. That gets a positive 24.6 u. Okay, now the book has that as the answer. They kept it in rectangular form, and that's fine. If not, if they said to do it in polar form, we would have to come up with a length and an angle to describe this original red vector up here, or the added vector, I should say. Right now, they're just wanting it in polar form. Okay, 11.8 units to the right, 24.6 unit up will be the addition of that orange and yellow vector representing that red vector. Hope that helps. Shoot an email or a text message with any questions on your homework. See you later.